All right, so we're diving in on number 4.
We did all of it?
Yeah, and what we learned on number 5 is that our little discussion about the one going up and the other going down, making it a candidate for inverse and the other way around, does not apply when one set of numbers is positive and one is negative, because then that switches things up a little bit. Okay, so we don't need to rely on that. What you should look at is what you should do with this is go 22 times 104 is what? 2288. And then you look at the next pair and you go 35 times 174 and you get 1690. 1690. And since those two answers are not the same, it's not inverse, okay? Then you do the opposite. You go 104 divided by 22 and you get 4.727, and then you do 174 divided by 35 and you get 4.97, and since those are different, it's not inverse either, so this one is neither.
Nice.
Okay? 27.
Wait,
What?
What? Divided by 9.
Was that a joke?
Okay, number 5 then, same deal. And I'll save us a little time. 2 times negative 4.8 is negative 9.6. 6 times negative 14.4 is obviously not negative 9.6, so it is not inverse. But then if I go negative 4.8 divided by 2, I get negative 2.4. If I go negative 14.4 divided by 6, I get negative 2.4. And then if I do the other ones, I get negative 2.4 also. And so that means that it is direct.
But I don't think it should be. Can you just tell us what?
Yeah, but one of them's positive and one of them's negative, and that screws that policy.
Okay, well, what if you just made one different?
Okay? So yeah, that's not necessarily a good way to live.
Is that your record?
My record.
Did you know that track, when we held our meeting, we used to win a race?
It wouldn't have surprised me this year if we just went over.
Oh.
Got totally
Yeah,
shut
we
out.
didn't take first.
We got like 2 golfers and then 10 total beginners.
Sometimes I'm a golfer.
Yeah, they're coming through. Okay, and then 6.
Okay, wait. Like, what is the 3 shoot? Let's be honest.
Morgan Gear was our 3 yesterday. She shot like a 70.
Kitty, we would be
Wow.
like 1 and 2 on that.
Oh yeah, you guys would have been right in them.
Yeah, you had 9 holes.
I don't understand that.
You should have golfed.
All right, so now this one, if you multiply these together, you get 36 every single time. And so that means the answer is inverse. Okay? So any questions about 4 through 6?
Yeah, wait.
If you multiply them together and it equals the same number, x times y equals k, then it's inverse. If you divide them and it equals the same number, then it is direct.
You said we can use this one for quiz.
All right, so then it says for 7 through 9, suppose that they vary inversely. So that means, just like I just said, that they're always going to multiply together to be the same thing. It says write a function that models the inverse variation. So for number 7, you could write xy equals, what's 13 times 7?
221.
221. Or if you want it to be in the y equals notation, you can write y equals 221 over x.
What one do they?
Y equals negative.
Either one's fine. The my answer book has this, but it doesn't matter. Either one's fine. So y equals, for the next
13
one,
times 17.
negative 48 over x. And number 9, y equals, what's a fourth of 52? 13. Negative 13 over x. Okay? So those are gravy, right?
I don't like the
No.
You like the what?
Not gonna hold this.
Oh.
Wait,
And again, the way that I got these numbers, negative 48, negative 13, 221, is just by multiplying the x's together, because that's what Varies inversely mean.
I can handle that if that's all of it.
All right, then number 10, 11, and 12, we have the old game where you're starting with this, you end up with this. How are they different? Well, what would this one be? It's a stretch because it's been multiplied. They took 4 over x and multiplied by what?
2.25.
2.25 or 2 1/4 gives you 9 over x. And so this would be a stretch of 2.25.
What?
How'd you get?
What?
How'd you get?
I went 9 divided by 4.
What did I put?
Okay? So since 9 is 2.25 times bigger than 4, the graph of 9 over x would be just like the graph of 4 over x, but it would be stretched by a factor of 2.25.
I just
So it's
Stretch of
So
2.25.
it's just stretched by 2.
9 over 4.
You just divide and that's the answer.
Yeah. What? Then you could say shrink. Okay, so like for example, this is 1 over x, you could say a shrink by a scale factor. Okay?
So how do you tell if it's shrunk?
Tricky now,
If
what
it's
happens
got
now?
a smaller.
Oh, this is right or left.
So let's do the 9 with the 3. Are you really? Is that really high? You said 4 over x.
Right, put it up 5.
Okay, so multiplying is a stretch or a shrink depending on if the number is bigger or less than 1. Adding or subtracting on the outside does what?
Up or down?
Up or down, and since this is plus 5, it is a, yeah, translation
Down.
up 5 units.
We just have 5.
Yeah, I'm a math teacher, so I have to make it all sound fancy and complicated, so that you think I'm smart. All right, and then 12 is a little bit tricky because they're not starting it right on the axis.
So it would be down 4.
Yeah, so you have to think about this plus 2 thing that you have originally would mean that the graph would be 2 up above, right? And then this minus 2 means that the graph would be 2 below. So how far has it gone down altogether? 4. Okay, so it's down 4. And then, right, same thing with x minus 1 would shift the graph how far, which direction? 1 to the right. So originally it would be right over here at positive 1. This plus 1 shifts the graph 1 to the left. So it would be left 2. Okay? This minus 1, since it's underneath the parentheses, it's like it's in parentheses. Okay? So it shifts the graph 1 to the right. From 0, it shifts it 1 to the right. This plus 1
I think it's right.
from 0 goes to the left 1.
And you count.
Yeah, in
It's
between.
right.
But how do you know it's to the left?
It's right.
Because it's-
It's right. It's right. It's right.
No, it's left because it goes opposite.
No, because
So it started at plus 1 and it
Okay.
ended up at
no, it
minus 1.
started as a negative.
No, because it's the opposite.
The book lied in.
Maybe they want us to do it in the opposite direction. Okay, and then we get into the fun ones we were working on yesterday.
I couldn't do number 13, but I did the rest.
Yes, that's 5.
I did the rest of those on the
Okay, so what do I have to do here?
That's 0.
Set the bottom equal to 0.
5.
I sure can. What can I factor it into, Ashley?
These are the ones I really don't.
Okay, so I have 2 discontinuities in this graph at
X equals -5.
-5 and positive 2. Are they removable?
No.
No.
Is that all we're doing no matter what it says?
I changed it on the quiz, so it'll say
Let's say what?
No.
To do the discontinuity, what kind of
that.
where?
It'll say nothing. You
What, do I
have
have to
a,
say if it's,
you have a blank quiz.
do I have to say if it's a,
And we had to write the
Non-removable.
problem. Is
Is that removable or non-removable? Non-removable. Okay. Next one is already factored for you, so that's 50?
Yeah, I was happy with that.
So it's got discontinuities at
-2 and 3.
-2 and at 3. And since I can cancel the x plus 2s, the -2 is removable. And the -3 is, the 3 is not.
Okay, so that's the multiply.
What?
The number 50.
Oh, okay, number 15. That's a multiply to be the last number and add to be the middle number.
Okay. That's the
Okay, so if I take the bottom and factor it, what do I get? Yeah, the bottom one factors into x minus 1 and x minus 1. So I have a discontinuity at 1.
Or does it go twice?
Is it removable?
One of them.
One of them is, but not the other one. Okay? Because if I cancel these out, then I'm still going to have a hole at x minus 1. At x equals 1. So I'm going to go with ultimately it's non-removable. Because you have to get rid of both.
Not one of them is? Can't use
Well, but they're both the same.
Can't have 2 1s.
Wait,
Yeah.
I'm confused.
Okay, so one of them?
So there will be a non-removable discontinuity in this graph at x equals 1.
No matter what.
No.
No, because it can't be both at the same time. You either have to be able to remove the stain or not remove the stain.
Well, are you talking about what state?
I just can't believe, it really hurts me that you're passing this class. It makes me feel like I'm a really bad teacher.
This is recorded right now, so.
I'm aware of that. It's okay, everyone can know. I cannot believe that if Lane asks, what's a discontinuity? They're calling me right now to fire me. That means ultimately,
Wait, what is it?
discontinuity at 1 and it's
You
non-removable.
remember this, Jenna?
Did we go all the way to 22?
Yeah.
Yeah, I know.
Yeah, nice job.
Wait, we stopped.
All right, 16.
Yes, -2, not the
16. There is a discontinuity at -2, and it is non-removable. Okay? How about 17? Discontinuity at 0, and it is non-removable. 18. Discontinuity at,
Too fast, too fast.
you have to do 18?
Yeah, we did.
Let's do
Okay. Discontinuity at -3, and it is non-removable. Okay, sweet deal. Number 18.
19, we just did 18.
No, I mean 19. Okay, let's, well, I can do a lot of factoring with this. Right, I've got the difference of 2 squares on the top.
How'd you get to 19 already?
And then what can I factor out of the bottom? That will leave me x plus,
3.
okay. So where is my discontinuity?
X plus 3.
When I'm,
No,
-3, and is it removable or non? Yes.
Without excited.
Okay?
I did it wrong.
So there's a discontinuity at -3 and it has been removed.
Wait.
Wait, remember what at 3?
At -3.
Well,
Yes, I'm getting frustrated. It's always opposite when it's in parentheses.
Because it has to equal 0.
Right, because it has to equal 0.
The 2 means nothing.
The 2 means nothing. No, because I can never make a 2 into a 0, so who cares? But the x plus 3 I can make into a 0 by making x equal to -3, not +3. Yes? Well, what you're doing basically with the 0 is you're taking the 2x plus 6 from the very beginning and setting it equal to 0. So how would you solve that? You'd subtract 6 and divide by 2, so that's where you get the -3. Okay? The other way that you think about it once it's factored is you can say if you have two things being multiplied together to equal 0, either this has to be 0 or that does. But since this can't, we only have to worry about this. Okay? All right, number 20. This is a good one. Okay, number 20. Let's factor the bottom. What can I pull out of an x cubed and an x? Well, an x. And that leaves me x squared minus 1. Okay? But now, hey, pay attention. Now that I have x squared minus 1, I can factor that into x minus 1, x plus 1. Okay? So a lot of factoring that you can do there. A lot of hidden factoring. So now I have a discontinuity at 1, at minus 1, and
0.
0. Good.
Why 0 though?
Because if I plug 0 in for x, then 0 times negative 1 times plus 1 is 0. Okay? Which one is removable? 0 is removable.
If you can plug in 0.
Because I can, cancel this and this. Okay? So the 0 is removable.
Everything else is this.
Non-removable are 1 and negative 1 because I can't cancel those.
Is it gonna be different?
Hope so. Be good to challenge it a little bit.
Okay.
Especially because I pretty much need lane to fail, so it's great to end up being what it should be. Okay.
No, he doesn't, Lane.
Starting Monday, bring my A B.
You're stupid. This one they just can't.
Wait, he's passing?
Yeah, that's removable, negative 3. I didn't know that. Or 3.
Okay, not even worth writing that one down. It has a discontinuity at 3. It is non-removable. Okay. All right, and then for 22.
So it's a positive 3.
It is removable.
It is removable.
Wait, it's not removable.
Jenna.
Not removable.
It was Jenna.
Because, no, they're not.
Factor.
It's plus and minus.
X out.
X out.
X minus 2 over. And then it's removable and add 2.